If you open almost any affirmation app, you are greeted by a professional narrator telling you who you are. The audio is warm, well recorded, and belongs to someone you have never met. That lack of familiarity triggers an automatic sorting mechanism. When a sentence arrives in an unknown voice, part of your mind files the incoming signal into a specific category: outside advice. Outside advice naturally carries friction. It is a claim about your life, made by a person who has no context for your history, your week, or whether the thing they just said is actually true. Because the source lacks that context, your mind does what it does with any unverified claim. It quietly argues back. This rejection is not a recording quality problem. A better microphone or a more soothing narrator does not solve the issue, because the issue is one of speaker identity. The entire affirmation category runs headlong into this barrier. The message fails to land simply because the voice delivering it is the wrong voice. Voice cloning offers a mechanical bypass to this problem. By capturing about 20 seconds of ordinary speech, a neural model maps the pitch range, cadence, and small habits of your speech. It learns exactly how you talk, independent of what you read. This is distinctly different from standard text-to-speech, which is a synthetic narrator and nobody's actual voice. It also differs from physical voice recording, where your library is strictly capped by whatever you are willing to sit down and read aloud into a microphone. Cloning bridges the gap between those two methods. It takes one short biometric sample and generates unlimited new audio lines, giving you your own voice minus the per-line recording effort. When an affirmation is generated specifically in your own cadence, it bypasses that initial acoustic rejection. The speaker is no longer a stranger offering outside advice. Substituting a stranger's voice with a synthesized version of your own shifts how your brain categorizes the incoming signal. To understand why that matters, we have to look at the neurobiology of how your brain processes the sound of itself. Information connected to yourself is processed more deeply and remembered better than the same information about someone else. The brain possesses a measurable biological preference for self-referential data. In 2008, Kaplan and colleagues scanned people listening to their own voice and a friend's. They found the brain dedicates a privileged channel to your own voice, specifically activating the right inferior frontal gyrus. This is not exclusively an audio processing center. This is the exact same region the brain uses to recognize your own face, indicating a representation of self that bridges multiple senses. A later study by Hasaka observed a pattern they called neural sharpening in the auditory cortex. When examining the bilateral superior temporal gyrus, they found that activation actually decreased for voices rated most similar to the listener's own. The mechanics here are highly efficient. A voice your brain has heard every day of your life takes significantly less metabolic effort to decode. It works less hard to hear you. That decreased decoding effort directly leaves your brain with more available bandwidth to process what the words actually mean. And when those words are self-affirmations, Cascio's fMRI research shows they actively engage the ventromedial prefrontal cortex and ventral striatum, your brain's primary reward circuitry. The physical structure of your brain proves a clear mechanic. It treats your own voice as a highly privileged, remarkably low-friction acoustic signal compared to any external speaker. But there is a critical gap in that foundational research. Every study establishing those mechanisms tested genuine recordings. None of them tested a cloned voice saying affirmations to you. That specific scenario was tested in a 2024 study by Joe and colleagues. They placed participants in an fMRI scanner and played them self-affirmation sentences twice over, once in their own synthesized voice and once in a matched external voice. The biological findings matched the prior models. The brain successfully distinguished the voices, showing clear interaction in the bilateral precuneus, a hub where self-referential processing meets autobiographical memory. This chart shows the subjective results from that same study, revealing a strict paradox. While the brain distinguished the audio signals on a physical level, the people consciously did not. When asked how emotionally impactful each line felt, participants rated their own synthesized voice and the stranger's voice exactly the same. The data showed a flat line, with no main effect of voice identity whatsoever. There was an unexpected counterintuitive finding. The scan showed the external voice produced more vivid visual imagery for the listeners than their own voice did. We have to contextualize these limits. This was a small study of 21 people hearing synthetic speech inside a highly noisy fMRI scanner, with no baseline check on how familiar the cloned voice actually sounded to them. While biological pathways prioritize the self-voice, current data proves this does not automatically guarantee a stronger emotional reaction. Anyone selling absolute certainty on the emotional power of voice-cloned affirmations is ignoring the fMRI data. This brings us to the core danger. Cloning your voice makes an affirmation far more personal. It does not magically make the statement true. In 2009, psychologist Joanne Wood had participants repeat, "I am a lovable person." Participants with low self-esteem felt actively worse afterwards than a control group who repeated nothing. An overreaching statement forces your attention onto the massive gap between the sentence you are hearing and your actual internal belief. If a stranger says something unbelievable to you, the friction is minimal. You can easily dismiss the stranger and move on. But if that same unbelievable statement is spoken in your own voice, the mismatch becomes much harder to shrug off. The speaker is no longer someone you can ignore. A synthesized self-voice acts as an amplifier. If the base statement is false, the clone only deepens the cognitive dissonance and generates severe psychological friction. The solution to this cognitive dissonance is a practice called graduated believability. This means crafting sentences that are plausibly, genuinely true for you today. This visual shows a standard, overreaching affirmation then. Claiming complete confidence in every situation is a statistical impossibility for almost anyone. By softening the phrase, you create a highly believable alternative. Noticing moments of confidence is an achievable action that avoids triggering the backfire effect. If you flinch when hearing a line in your clone, that flinch is incredibly valuable data. It signals the line must be softened until it lands as honest rather than performative.